Alright, I'll do 1 to 4. So you have this diagram, coordinate geometry. AC is 3x plus y minus 3. So AC is this line here. Yeah, so it's got x-intercept. You can do lots of things. You can write the equation, like that's like the general form of the equation, right? So you could just write like ax plus by plus c equals 0. And then you could just sub in like 1, 0. So here it's 1, 0. You get a plus c equals 0. So that's why 3 is equal to minus 3. They're the same. So a equals minus c. And you could literally, like, if they're not 0, so if a and c were both 0, then you get like y equals 0. And it's not y equals 0, because that's the x-axis. Then you can actually just set them to be 3 by dividing by something. But maybe don't do that just yet, especially in this context. Maybe it's easier just to sub in minus 1, 6. Okay, so then you sub in minus 1, 6, you get minus a plus 6b. And then c is also minus a, right? Equals 0. So you get 2a equals 6b, or a equals 3b. Okay, so then your equation becomes, so you can maybe leave the b, so it's by 3bx, and it's minus 3b equals 0. Okay, but then there's a common factor of b, and as long as b is not 0, so you get b is not 0, then 3x plus y minus 3. I think I showed a different method last time. So another thing you can do, now that I mention it, you know how I said it's ax plus by plus c equals 0, yeah? Actually, what you can do, it's actually because the question gives it to you, you can actually just take this to be the equation. It sounds circular, but it's not. So you take this to be the equation, right? You know this is the equation of a straight line. So to prove that that's the right equation, you just need to sub these two values in and see that it works. So if you put in x equals 1, y equals 0, you get 0. And if you put x equals negative 1 and y equals 6, you get 0. So then that's the equation of the line. Okay, so yeah, so there's lots of ways to do it. The fact that they give you the answer is actually, it changes the difficulty of the question immensely. It makes it much easier. Sometimes it makes it harder because you can't get marks for finding the answer. Hence, find the angle AC makes with the positive x-axis. So AC, so the angle things make with the positive x-axis is related to the tan of the angle is equal to the gradient. So here y equals minus 3x plus 3. So this is the gradient. So tan of this angle equals minus 3. So the angle is just, so if you do it on the calculator, inverse tan, it'll give you a negative acute angle. But what you want is you want an obtuse angle. So you got to convert it into an obtuse angle by adding 180. Okay. Okay, sure, AB is perpendicular to AC. So you guys probably should already know that 2 slopes times the -1 means that the 2 lines are perpendicular. So what's the slope of AB? So the slope of AB is the rise is 1, then the run is 3, so 4 minus 1. And the slope we had before was -3, right? And if you times them together, you get -1. Find the length of AB and AC. Okay, so this is the distance formula. So AC, so the length squared, I guess, so AC squared equals, so the distance is just 2 squared plus 6 squared. And AB squared equals 1 squared plus 3 squared. So then the lengths are, this is like 40, this is 10, so it's like root 10 and root 40. So this is 2 root 10, and sorry, this is, so AC is root 10 times 2, AB is just root 10. So AC is twice AB. Hence, by considering, okay, so maybe I didn't note, theta was already taken. A, B, C. I shouldn't have used theta before. The angle theta was already taken. The ABC is that angle. There's actually a formula to find the angle using the gradients of the lines. But here it looks like, considering the right angle triangle ABC, because we're told that's 9 degrees now, right, from part 3. Oh wait, Slava's doing 5 right now, so have you done 5 already? I'll give you more time, okay, maybe you'll finish it all by then. Okay, I'll give you a pause. Okay, so we're up to find the value of theta, which is here. So this 90 degree makes it easy because theta will be 10, whatever the AC is on BC, right? So you have the lengths. I think it was just 2, right? So tan theta equals 2. And so then you put in your calculator, and tan theta should be some acute angle. Find the coordinates of E, the midpoint of AC. Oh, that's weird. I thought you were just given a formula to find the midpoint. I mean, it might be harder if you were to prove it's the midpoint, but so AC. So you just average the coordinates. So it's gonna be what's on the y-axis, and the height is gonna be 3. Oh. That's pretty straightforward. So 0, 3. It's the midpoint. Find the area of triangle CEP. Area of triangle CEB. So E is the midpoint. CEB. Actually, it's a funny one. Like triangle CEB. Like, I don't know if you know this, but it's like half the area of the triangle ABC, because it's like half the base times the same height gives you half the area. So so the area is just AB times AC on 2, but then you're halving it again, so it's on 4. And it was just 2 root 10 times root 10 on 2 times 2, so the 2's cancel. You get 10 on 2, which is 5. that what you guys got?
Pretty much. I did it differently. I got a decimal.
Shouldn't be a decimal. It was 5. Actually, did you know that there's something that's not in your syllabus, but there's actually a formula to find the area of a triangle given 3 coordinates. So you have minus 1, 6, 4, 1, and we have 0, 3. So this is a formula. It's kind of, you put 1s here, and you calculate this thing called a determinant. And what you do is you do 4, so you do these boxes like 4 times 3 minus 0 times 1, and you do that kind of 3 times. So 4 times 3 is 1, minus 0 is 1, and then now you take this one and you take this box, like the 4 numbers here. That's minus 1, minus 6, so minus 3, minus 0. But this is alternating as sign. I'm just explaining what the formula is, not why it's true. Okay, so don't get too confused. So it's just 3, and then here it's a 1 times this box, which is negative 1 minus 24, which is negative 25. Wait, something's gone wrong here. There's something going on. Let's take the absolute value of this. It's negative 1 minus 24. What's minus 25? Oh wait, the first one is 4 times 3 is 12. I don't know why I did 4 minus 3, it's for times. You find the difference of the product of the diagonals for each box. And then the other one is negative 3. Yeah, so this is 15 minus 25 is minus 10. Is 5, yeah? So the area is, take the absolute value is 5. Yeah. I mean, that's like the way to do it if you have no idea what's going on. But like if you see it's a right angle triangle and that's half the base. Find the coordinates of, find the area. Yeah, so we just did those. Suppose F lies on BC such that EF is parallel to AB. So F lies there. Prove that triangle CEF is similar to CAB. Oh. Yeah, I mean, it's kind of weird. I mean, what's there to prove, really? So EF has the same slope as AB. So you can use that to show that it's 90 degrees. So EF is perpendicular to AC. So it's got a right angle there. You could say that you could say what could you say? You could find the angle again, but that would involve finding the length. I mean, you could just say the angle's the same because it's parallel, I guess. No, actually, no. Oh, there's a common angle at the top, even. It's actually kind of a silly question. It's like totally unrelated to the, sort of the, what would you say it's called? The kind of like the storyline of the problem. Hence, find the length of EF, give reasons. Okay, well, obviously, if they're similar, EF is half the length of AB, right? So, AB was root 10, so length of EF is root 10 on 2. If you want to write that properly, it's like, oh, the corresponding things on similar triangles are the same ratio, so this is half of that, so this is half of that. And then this, and this is root 10, so half of root 10 is root 10 on 2. Which is also root 5 on, like this. Alright, you guys have any questions about that?
No.
Makes sense?
Yeah.
Is it basically what you guys did? Or different? Similar? Different?
I did question 7 differently, but I don't know if I did it right.
Oh, well, I guess your answer might need to agree, or we might, well, I might have got the wrong answer. Well, what is the, what did you do?
Because I got 5, but I got a decimal after, so I did so CE is half of CA because it's the midpoint.
Yeah.
So that's root 10.
Mm-hmm.
And then since it's a right angle triangle, I used Pythagoras to find CB.
CB. Okay.
Yeah, because the length of CB doesn't change. So I got 5 root 2 for CB.
Mm-hmm. So it's 10 plus root 50, yeah. Root 50. CB. Root 50.
Yeah, yeah. And then for I to find the area, um use like the non-right angle triangle area thing. So you find the angle of C. I just did angle sum of a triangle. I did angle sum of a triangle, which is like 90 minus 180 minus 90 minus theta.
Mm-hmm.
And theta is 63. So
Yeah.
the angle is equal to 27.
So you did half sine something?
Half times root 10 times root 50 times sine 27.
So sine 90 minus theta. Yeah.
Yeah.
Yeah, I think the problem might just because you put it into your calculator here and it'll give you something rounded and it might just be a little bit rounded too early. I don't know. That's how
Yeah.
I mean the approach is sound. So what's root? So root 500. So it's half root. So it's 10 root 5. Yeah. Cos theta. See, if you notice tan, like we know tan theta is 2, right? So we should know what cos theta is. Cos theta is it's basically root 10 on cos theta is root 10 on root 50, right? Alright. So this is 5 root 5 times root 10 on root 50. Actually, it'd probably be better if I didn't simplify this and left it like that. Because then that'll be half root 10 times root 50. And the root 50's cancel. And the root 10's times together you get 5. So you get 10 over 2, right? Which is 5. Yeah, I think it's because you rounded the angle.
Oh, okay.
If that makes sense. It would have been extremely close to 5, right?
Yeah.
5.00 something?
Yeah.
Okay.